Good day. I'm going to talk about graphene-based wearable gas sensors. Have you ever encountered how a silent but deadly fart smells like? A Korean scientist had the idea that we can now use wearable sensors to detect certain gases. Dr. Hyung Kun Lee and his team from the Electronics and Telecommunication Research Institute is working on graphene-based wearable gas sensors that may help detect nitrous gases that may cause acid rains in the surroundings. Using these wearable gas sensors, the LED bulbs light up when the gas concentration is as low as 250 ppb at room temperature. This means that it has the potential to be used within factories to detect leakages by attaching the sensors in lab suits that workers wear. Dr. Lee also noticed that there has been an ongoing trend lately that the textile industry will boom with the advent of smart clothing. Let us tackle the science of how gas sensors work. Gas sensors have a certain component within the device, such as smoke detectors, wherein the mechanisms vary from each specific property. A normal smoke detector uses reduction oxidation mechanism since it boosts the performance of the detection process. But other devices such as the work of Dr. Lee and his team utilizes the change in resistance as the measurement of sensing the gas. There are various other mechanisms which are specific to a particular system, such as the acoustics, where you can use in dealing in ultrasonic gas detectors found in oil or gas platforms, compressors, and metering stations. Given the different applications, problems do arise. With the goal of making wearable gas sensors, you want the device to be sensitive enough to detect the gas. It should also be specific as to what gas it is and flexible so as not to break the device. Back to the study by Dr. Lee from ETRI, they combined both graphene oxide and bovine serum albumin with the yarn to generate the sensor. Graphene oxide was produced through the use of modified Homer's method together with strong oxidizers such as sulfuric acid, sodium nitrate, and potassium permanganate. The BSA protein acts as a nanoglue that allows the graphene oxide to electrostatically self-assemble itself towards the yarn. The yarns were either cotton or polyester. These yarns were then reduced with hydroiodic acid to generate the reduced graphene oxide. RGO, or reduced graphene oxide, then is used to measure the change in resistance of the target gas. Notable advantages of this idea is that it is ultra-sensitive with 250 ppb at room temp with -6 response, as low as -6 response, flexible, meaning 1000 cycles of bending and straightening of the yarn, regenerative, indicating that after use after a lifetime of 15 days, the addition of UV and heat will regenerate the capability of the yarn to detect gas again. And finally, washable, indicating that 10 washing tests with detergent gives out that the yarn is still ready to use. There have been loads of avenues for e-textiles within the industry. In fact, if you look at the country's manufactured products, textiles are set at 39% of the total manufacturing industry in terms of revenue. This means that our country deals with 39% of the total industry in terms of textiles. This promotes trade within and outside the country in terms of clothing and textiles. Also, another chart here states that the fiber industry is projected to grow even until 2030, which indicates that fibers for daily use will greatly benefit from this. Alongside the rise of the textile industry, huge companies such as Adidas, Nike, and Levi's have growing interest into smart clothing. In fact, Adidas launched a clothing line that regulates temperature through devices embedded into the shirt. Also, Google through Project Jacquard aims to develop a commercial product through embedded electronics for various applications such as captured and motion interactions. This changes the way we see clothing. But wait, sensors are not only found in clothing. A patent by Dr. Benjamin O'Brien and his team from the University of Auckland, New Zealand, created a patent that allows sensors to be embedded in different systems, such as car seats and in polymer coatings. Key findings of this patent include flexible sensors even when stretched, new designs that involve encapsulation for moisture detection, and applications such as automotive and kitchenware. Similarly, the mechanism behind their work involves the change in resistance and capacitance, such as like the work of Dr. Lee and his team in Korea. Augmenting the two ideas, not only shirts, now can be considered smart. The possibilities are endless. You can have as simple as speedometers on your shirt to a SWAT alarm on your polo. This is why perhaps smart clothing is the next big thing in the global scale. Here are my references and image sources. Thank you for listening.